Zero here, and I'm happy as a goddamn clam. You want to know why? Because I have one of these. There's only one little problem. It doesn't fucking work. So that's something I'm sure we've all done before. You get nice and excited bringing home your brand new console from the flea market or opening that box from eBay and, surprise, it doesn't work. So today, we're going to teach you how to take apart a Dreamcast and troubleshoot it. And we're going to start with the power supply. So first, there's 4 screws holding the bottom of the thing together. And one of them is hiding under the expansion bay there. So there's 1 screw there, 1 screw there, 1 there, and 1 there. 1 in each corner. And just so you guys don't have to sit here and watch me unscrew for half an hour, I've already taken them all out. So once you get all 4 of these out, and don't lose them, flip the machine over, and the top just pops right off. To Sega's credit, the Dreamcast is really easy to work on for a late generation console. Really, there's only 4 parts to it. There's the GD-ROM unit, or the reader, there's the power supply, there's the port block on the front, and then underneath is the main motherboard. And really, there's only 3 things that can go wrong, or 3 things that commonly do go wrong, which is good because those are the 3 things we can screw with. That's the 3 on the top, the GD-ROM, the power supply, and the port block. Now, since we've realized that our Dreamcast here doesn't actually turn on, we're probably going to suspect the power supply. If you're going to have problems with the console, you probably want those problems to be with the power supply. Commonly, only one thing goes wrong with them, and that's dried out or blown up capacitors. You can see there's a lot of big electrolytic capacitors on this thing's power supply, and there's been big problems in recent years, and I say recent years, I mean like from 1995 on or so, of cheap capacitors coming from China that everybody builds into their stuff, and after a few years they either dry out or short out and they don't work anymore. So for our example today, we're going to go to my wall of deceased motherboards and silly masks. Yeah, don't mind that. But anyway, if we climb up here to this board, we've got some capacitors that are good and some capacitors that are bad. And sometimes you get lucky, and you can tell a capacitor's bad just by looking at it. For instance, these ones that I'm zoomed in on here. If you look at them from the side, you can see how the tops are kind of puffed up and bulgy there. That means that they've blown up. And if I could pull one of these off, actually I'll try that right now. You can see that the little rubber plug on the bottom is blowing out a little bit too. That's a safety mechanism. That's so that when the electrolyte in these things boils, it doesn't explode. Well, up here, we've got some identical caps, but these ones are still good. You can see the tops are still nice and flat, and they're not puffed up. So if we had to replace a capacitor, we could take one of these and it would probably still be good. So here we are back at our Dreamcast board, but we have a problem. All of our capacitors still look pretty good. So, if we think our power supply is the problem, how are we going to troubleshoot it? Boy, am I glad you asked. The way the Dreamcast is put together is actually really fortunate for us. Sega put the thing together in such a way that it's actually kind of easy to work on. So, this connector here is the whole thing that gives all the power from the power supply to the rest of the machine. And you'll see, if you look at it closely, it's even marked for us. 3.5 volts, 5 volts, 12 volts. So if we were going to look for another power supply to put into this thing, any idiot who's clocked more than 5 seconds inside a computer case ought to recognize those 3 voltages. So yeah, you say, but Zero, you could go on eBay and buy another power supply or a broken Dreamcast for like another 20 bucks. But you know what? Screw that. We're going to cheat. Really, the name of the game here is troubleshooting. We think it's the power supply that's bad, but we're not sure. So, are you going to drop 20 bucks on a new part just to slap it in there and find out it's really not what's wrong with the machine? I'm sure as hell not gonna. So before we do that, we're going to rig this PC power supply in here and see if we can make the unit work at all. If we can make that happen, then maybe we can take apart the existing power supply and fix it, or failing that, we can go on and buy a new one online. Luckily, taking out the Dreamcast power supply is really easy. First, we've got our power switch here with a big gray wire that runs up to this plug. There's a little clip you can press on it, kind of like an automotive electrical connector, and just pop it right off. Then there's just 2 screws that hold the power supply board into the machine. There's one there, there's one right there. So we'll go ahead and take those out. And we'll be sure to tuck those away so they don't get lost. Now, there's a little plastic clip that holds the power supply into the board. And you can just see it on the left-hand edge of the board right here. If you pull that back just a tiny bit, and then lift up from down here by the power connector. Now the power connector is friction fit. It's got little spring-loaded gubbins in there that grab these pins that go down to the main board. So once you have that off, the whole power supply board should lift right out. And there's our 6 pins. You can see these actually go all the way down through the shielding to the main board in the machine. Are you following along with this next part at home? Good. Here's some advice. There's a few things you need to have if you're going to do this. 1, a brain. Really, don't be a retard. 2, a bent-up piece of a paperclip, or anything conductive. 3, an ATX power supply. 4, a multimeter. I have this little stupid Radio Shack when I got on clearance for like $8 or something. Really all you need is something that shows DC voltages. If you don't have one of those, and you're smart, and you follow my directions exactly, you can get away without it. It's a good thing to have. You're also going to need some way to connect the PC power supply to the Dreamcast. I like using these little Stay-Con crimp connectors here, because if you adjust them right, you can just plug them right into the pins on the board, and they'll stay there. Now the ones I'm using are uninsulated because they're smaller, and I can get away with it because I know what I'm doing. But if you're an idiot, or you don't trust yourself, use insulated connectors and wrap a little bit of electrical tape around them, because if I have to tell you why shorting these things together would be a bad idea, you should not be doing this. So here I am connecting my little Stay-Cons to the board here. 6 pins, so I have 6 Stay-Cons and 6 wires. And I'm connecting them in this staggered pattern just because it makes them a little bit easier to work with, and it makes it a little bit harder to short them together, since, as I said, my connectors aren't insulated. Notice I'm connecting these first, so I can make double damn sure everything's connected right, nice and secure, and none of them are touching each other, before I plug them into any power source. Here's where the attention to detail comes in. You paying attention? You better be. Alright. An ATX power supply, you'll notice, doesn't actually have a power switch on it. If you want to make it turn on, you find the green wire here, and you short it to any of the black wires. All the black wires are grounds. So you take your special paper clip of science here, and we're going to connect the green pin to a black pin. Now my power supply is not even plugged into the wall right now, but if it were, it would turn on. I've got it unplugged and turned off with a little switch on the back, just in belt and suspenders, make sure, because we don't want any power going to the unit before we have all the wires plugged in and we're sure they're in the right spot. Now, flip this over, and ooh, look at all the little pretty colors, a whole rainbow of wires. Alright. All the orange wires on a standard ATX plug, 3.5 volts. All the red wires, 5 volts. The yellow wire, 12 volts. Hey, don't those numbers sound familiar? That's exactly what our Dreamcast wanted. If you're not sure, make sure. Get out your multimeter, put the black to a black, and test all the wires. Orange, 3.5 volts. Red, 5 volts. Yellow, 12 volts. And bear in mind, what I'm telling you here is only a guideline. This is the ATX specification. If you have a regular power supply, bog standard, made to spec ATX, those should be the wire colors that correspond with those voltages. But if you don't have a standard power supply, I don't know, you get a Dell or some stupid crap, or you have some Taiwanese piece of shit that you bought at a flea market and you don't know what the hell it is, check first, because they might not have wired it right, or they might have used different colors or some goofy ass thing like that. If you're not sure, make sure. Now it's time to bring it all together. If you look at the old board, the old power supply, it's marked right along the bottom edge there with what pin is what, and here's the order. Pin on the far left is 3.5 volts, then 5 volts, then 3 grounds, then the 12 volt wire. So we're going to start all the way at the far left, plug that into our orange on the ATX connector, that's 3.5 volts. And we're going to go to the next one, that's 5 volts, it goes to red. I'm going to skip down to the far right end to yellow, it's 12 volts. And then our 3 grounds. It doesn't matter which black wire you plug these into as long as they're plugged into something. They all go to the same place on the ATX power supply, and I would imagine they all go to the same place on the Dreamcast too. There's just more of them so it can handle more current if it has to. So now we've got all our little wires plugged into our connector. And if we're double damn sure they're all plugged into the right place, we can light it up and see if we let the smoke out. Now remember, all we're doing here is troubleshooting. I want to see if we can make the thing work at all. So right now, I've got my ATX power supply turned off. Can't really see the switch down there, but it's off. So we've got it plugged into the wall. We've got it plugged into our Dreamcast. I'm going to turn it on. Aha! Little orange light. It's alive. So our problem was with our power supply. Now if you want to test the Dreamcast further, since you've got the top off, it'll actually refuse to read discs. Snap a disc in there, there's a little black switch up by the upper right hand corner here. When you close the lid on the casing, that's what lets it know that you've got a disc in there. So we'll just push down on that. It should take off and start reading. So let's plug this bugger into the TV and see if it works. Now I know my little setup here is not ideal, but we just have to roll with it because, seriously, I know this is sad, but that's the only TV I've got. So we've got all our unholy amalgamation of wires set up down here. And you'll see on the upper corner of the Dreamcast there, I just took the modem module and kind of laid it across the switch on the top so it'll think that the lid's closed, so I don't have to stand down there like an idiot and keep my finger on it. And when you move your stuff over to your TV, if you're not already at your TV, you better be smart and make sure all your wires stay connected and all in the right place and everything so you don't blow anything up. So now that we've got everything connected and I've got it plugged into a TV with our Frankenstein power supply, see if it works. We get a disc. We have boot up. We have a loading screen. We have Ikaruga bitching at me because I don't have a VMU in my controller. And I dare say we have a winner. So today's troubleshooting exercise is a success. We figured out that the power supply is our problem, and now that we know that, we can move on to fixing it properly. Yeah, I know you whiners. Now I can go to eBay and buy a new power supply, right? Well, yeah, I guess I could if I really wanted to, but I don't. And if I did, you really wouldn't get anything out of this video, now would you? So the first thing we're going to do is start with the most obvious. This little black sucker up there in the corner, that's a fuse. It's rated at 2 amps. If you flip the board over, you can see there's actually a marking for it in a little circle there. So before we do anything, we're going to make sure that fuse isn't blown, because boy, that would keep our power supply from working, wouldn't it? So I've got my multimeter in continuity mode, so it'll beep every time it gets a short circuit between the probes. And we'll hook it up to that fuse. Alright, it beeped, that fuse is good. So the next thing we're going to do is start looking at capacitors. because if it's not something really simple like a fuse, 99% of the time any problem with a DC power supply will be the capacitors. There's other components on there too. There's transformers and a couple of big old rectifiers. Those are pretty robust and usually they don't go bad. The electrolytic capacitors though, these are these guys with the shiny silver tops and the plastic sides. Those actually have a liquid electrolyte in them that over time can dry out. And the cheaper the capacitor is, the faster it'll dry out, or it could just fail altogether and explode, but obviously that hasn't happened in this case yet. Digital multimeters and even some analog ones actually have a mode to test capacitors. And since mine's a cheap piece of junk, it doesn't. So here's how to do it with a regular multimeter. First, if you look at the rating on the side of a capacitor, it'll tell you it's farad range, that's basically how much energy it can store, and its voltage rating. So the first thing you have to do to test a capacitor is discharge it. And the safe way to do that is with a resistor, but you have to do a lot of calculation to figure out what kind of resistor to use and so forth. So if you've got a capacitor whose voltage rating is within the maximum allowable voltage of your multimeter, all of them fit within mine, you can just discharge it by putting your multimeter in voltage reading mode. You can hook it up to the terminals, and you'll be able to watch the voltage go down. This one's actually already pretty empty. So once you hit 0 or close to it, switch your multimeter over to resistance and hook it up to the contacts of the capacitor. And you should be able to see the capacitor charge. Since I've got a digital multimeter, and this is a small capacitor, it actually charged up really fast. So your resistance should start at 0 or close to it. And as it charges, it'll rise until it hits infinity, and it's already done that on my multimeter because this is a little cap. So if it does that, you know the multimeter, or you know the capacitor is holding a charge, and it's not leaky, and obviously it hasn't exploded, so it's probably still good. So just do this with each capacitor on the board and keep moving on until you find one that gives you a funny reading. So I've moved right along, and frankly I've spared you the boring half hour of poking and prodding all the stupid capacitors on this board, just so I can turn the camera back on and show you this. Aha! We've got a capacitor that's just open circuit, infinity resistance immediately no matter what I do. And if I put the multimeter across it and try and check it for voltage, I get nothing. So what we have here is a capacitor that's just completely removed itself from the circuit. And looking at those two contacts there, if we flip the board over, oh boy, we can see it's that big huge guy right there. So obviously when a capacitor goes entirely open circuit, it just doesn't work and you get no voltage in your circuit at all. And that's exactly what we saw, right? Press the power button, nothing happens. So what we're going to have to do is we're going to have to unsolder this capacitor. We can almost read its specifications down the side there. And hop on the internet, go to Mouser Electronics or maybe even Radio Shack, buy a new one, and solder it back in. So that's all there is to it. With about, I don't know, $1 worth of parts and a little bit of time, a little bit of testing, we can take this dead Dreamcast and we can make it live again. And that's how it's done. Alright, so I don't have another capacitor right now, and it's not going to be here for another week or so. So I figure while I have the cover off of the thing, I might as well show you how to take apart the rest of a Dreamcast just in case you ever run into any other problem. So like before, power supply board's very easy to remove. Just take out the two screws, take off the plug, and lift it off with a connector. Here's another common problem that can manifest itself. These 6 pins here, and their accompanying connector on the power board can get dirty, and you can have galvanic corrosion happen there, or just plain old get dust and dirt and grime on them. And if they get all grimed up, then you'll have high resistance between the power supply board and the rest of the unit, and that can give you power supply problems as well. And this is a common problem actually with older Dreamcasts. We read about it a lot online, where people will have a Dreamcast that'll play a game for a little while, and then when the action gets heavy and the board and the GD-ROM unit start drawing more power, boom, the thing just resets. 9 times out of 10, that's the problem. And there's a couple of ways you can deal with that. Of course, probably the best way is to get out your handy-dandy can of automotive electronic contact cleaner, which actually isn't the recommended stuff for this, but it's what I recommend and it works really well. Just spray that onto a little cloth, give these guys a wipe, get all the grime off of them, any green stuff, any black stuff. Make sure you get them cleaned off real good. If that doesn't do the trick, you can use a piece of really fine sandpaper, like 400 or 600 grit, on the pins. And if you're still having problems, There's actually a little gap in there. These are spring-loaded on this connector. You can floss those out as well. And if that's still not doing it, or you want a more solid connection, you can actually grab these pins one at a time, just bend them towards the back of the unit a little bit. You can actually even just use your fingers just like this. Now you want to be careful you don't snap it off down at the bottom of the board. So hang on to the nylon part and just push them out just a few degrees. So when you put the power supply board back on, you're going to have more tension and a more solid connection between those pins as they push back on the spring-loaded part of the connector, and that should give you a more reliable connection. The other major part of the Dreamcast that can have problems is the GD-ROM unit. And in order to take it off, there's two things you can do. One, just like on a PlayStation, the top of the unit actually isn't attached to anything at all. It just kind of rests on these little rubber grommets here for vibration isolation. But on the underside, it's got a ribbon cable, and it's still connected to the rest of the unit. So you can actually just flip that up and pull that ribbon cable out, but it's a real bear to get back in. And if you need to look at any other part of the unit, there's 3 screws, one there, one back in there. So the plastic piece actually comes off. If you take those 3 screws out, the entire GD-ROM assembly can come off. And I keep saying GD-ROM, not CD-ROM, because it's actually what it is. Just like the Saturn, this thing reads Sega's proprietary GD-ROM discs, which are not quite a CD, not quite a DVD. Nobody knows what the heck they are, but they're proprietary. So those 3 screws out, kind of rock this whole assembly up a little bit, and hang on to this, the top part, because it's not connected to anything. There actually is a little connector there that plugs into the main board. Underneath that is a big shielding plate that covers the entire motherboard of the unit. There's a few other points of interest here. One is the controller block, just down here. There's actually a little, I think it's a rechargeable battery, a little NiCad or a nickel metal hydride there that stores all the clock settings and so forth if you unplug the unit. If you get an old Dreamcast or you buy one from somewhere and it's been used and sitting around for a while, and they've all been sitting around for a while now, but especially if it hasn't been plugged into the wall for a long time, this battery will be dead. And it'll charge if you leave the thing plugged into the wall for a while, but obviously it'll lose its time and date and all its settings. If you have a really old Dreamcast or one that's been abused or used a lot or really left unplugged from the wall a long time, this battery can be totally dead and it won't even charge. So it's usually tack soldered to these little tabs here, but it's easy enough just to heat it up, pull it out, and replace it with a new one. You can just use a regular watch battery if you want, or you can special order a little rechargeable cell to stick in there. You can also run into problems with the controller ports, which are pretty well documented online. This whole board comes off if you take off these 4 screws. There's one on either side of the 2 pairs of controller ports, along with a ribbon cable that connects it to the rest of the board. This is also where the fan connector is, and the fan is a high maintenance item in the Dreamcast. You can see, after I get this screw out, it's actually plugged in on the board right behind the controller block here. And if you grab this connector, it just pops out, and sometimes it takes a little plier coercion. When you do this, be sure to grab the top of the plug and not the wires. And the fan is, well, it's metal shrouded, but it's actually a fairly standard small computer fan sort of thing. And if it starts getting noisy or giving you a lot of problems, you can actually lubricate it with some Tri-Flow or some sewing machine oil right through that little bearing hole there. And that can give your fan a lot more lifetime, can solve a lot of problems with the console. Underneath of this port block, which is not strictly necessary to remove for most cases, if you take this off, you can get at the underside of it and unsolder the LED, put some kind of funky colored LED in there if you want, blue or purple or something. And there's also this small ribbon connector that connects it to the board. There's no retainer on this, so if you get under it carefully with something, it just pulls right out of that socket. And with that, the controller port board comes out. We can see all the screws. There's 1, 2, 3, 4, 5, 6, 7, 8. that all hold the shield onto the main motherboard. I skipped removing all the screws so you don't have to watch all that again. I've gotten all the screws loosened here. Okay, most of the screws loosened. The shielding plate lifts out. And we can see the Dreamcast Katana motherboard. That's what it says right down on the bottom there. There's really not a whole lot of discrete components on this board. If you have to tear the machine down to this level, other than just to check on and clean the heat sinks and heat pipes here, then the motherboard's probably toast and there's not a whole lot you can do about it. There are a few mods you can do, which I'm not going to document here, like adding VGA output and so forth. And there are a couple of discrete components. There's a few polymer film capacitors along here, but those are really reliable and they almost never go bad. So basically this is just an exploratory thing, kind of an instructional experiment, so we can see what the main board is and how simple it really is. And it's actually kind of nice to work on the Dreamcast because everything comes apart from the top. There's almost no fiddly little ribbon cables. Really the only one that's difficult to work with is that one on the GD-ROM. And it's a really nice machine to have to work on if you're going to work on it. And because of its modular design, it actually is really easy to repair old Dreamcasts. It's pretty easy to find them online, and there's a lot of busted ones out there. Obviously I got a busted one right here. But because of that modular design, even if you're not into replacing discrete components and whatnot, you can just pull modules out of old units if you have one that you suspect, you know, I've got a bad power supply here or a bad GD-ROM reader there. You can kind of play Lego with the thing and swap them out, move parts around, and build yourself a working Frankenstein unit pretty easily. And all you really need to do to take most of the modules out is get your hands on a Phillips head screwdriver and away you go. So you can see, in just the short amount of time it took me to tell you that, I've already got the thing halfway together. It really is a very easy console to work on as opposed to, say, an early PlayStation 2 or even worse, one of those slimline ones, or even older stuff like Nintendo's, and SNES's and Genesis's. How do you pluralize Genesis anyway? Well, anyway, all those older cartridge-based systems go together all kinds of weird ways, and the Dreamcast really just doesn't. GD-ROM unit back on. Actually, while I'm at that, hang on. Let me show you a few points of interest here. The ribbon cable that holds this thing together here, sort of, that connects the laser lens assembly to the rest of the GD-ROM board. If the lens is all the way back, you can just tilt this up a little bit and you can kind of see what's underneath of it. There's a few things you can mess with here. There's the motor that moves the arm back and forth. There's a little tiny trim pot there that you can use to turn up the laser power, kind of like you used to be able to do in the old PlayStation 1s. I really recommend you don't mess with that unless you're having serious disc reading issues. It's probably a better idea to clean your lens and everything before you resort to that. And both the traverse motor and the spindle motor are actually standard off-the-shelf parts. You can order those, not as Dreamcast parts, but you just look up the part number on them and the dimensions, and you can get them from Mouser and other electronics suppliers if you run into problems with them. On the underside of this, something that hangs up a lot of people who are going to mess with it. There's 3 visible screws here, 1, 2, 3. But you can see I've kind of cut away here. There's 2 more holding this shielding on that are underneath this padding area. If you take those 5 off, you can get at the board on the underside, but there's really not a whole lot you can service there. Again, there's a few more of those polymer film capacitors, but 9 times out of 10 you don't have to mess with those. But if you find yourself doing the modular replacement game, often you can get just this black part as a GD-ROM reader if your board is still good. And you have to take off that shielding. There's 3 screws underneath of that let you take off the entire black plastic part of the GD-ROM unit. So you can see, in just about as much time as it took me to ramble on about all that, we have the unit back together. And actually, if I plug this in, if my power supply still worked, we'd have a working Dreamcast. And that's how simple it is, folks. So while I'm putting this thing back together, let me say 3 things about discs. 1. Did you know that the Dreamcast is actually an early enough console that you don't need a mod chip to play burned CDs with it? Yeah, it's true. Check it out. Regular old burned CD, you know, one just like this. That'll work in the Dreamcast, no problem. Now, while you're researching online to find out about troubleshooting issues and whatnot, you probably hear a lot of lip from morons on forums about, oh, you can't run burned games forever on your Dreamcast, it'll wear it out. That's bullshit. There's nothing different between a burned CD and a pressed CD as far as the Dreamcast is concerned. There's no way that putting a burned CD in will make the laser consume more power or make it overheat or any of that bullshit. All these prepubescent morons who are giving you lip about this are all just idiots who can't figure out the correlation between cause and effect, and they haven't figured out that the reason their Dreamcast wore out is because they downloaded 1,000,001 games off the internet and had their Dreamcast running, spinning, and playing games for 36 hours straight, never gave it any time to cool down, never cleaned it, never maintained it, never did anything to it. Nope, now it's broken. So while we're on the subject of cleaning, I'm actually going to take this back off because my lens is parked way the hell up there. Here's the proper way to clean the lens on, well, anything that's got a lens on it. Use alcohol. I use this stuff. Okay, it's probably overkill, but it works. Isopropyl alcohol will be fine, you know. Methylated spirits, denatured alcohol. Don't use Windex. Don't use water. Don't use contact cleaner or any of that other stupid crap. Especially don't leave anything that leaves a residue. And just put a little bit on the end of the Q-tip. And you really don't want to press down too hard. Just little circles. Get every surface of the lens. Get all the grime off of it. And with the dry side of the Q-tip, wick up any excess moisture. And the whole reason for using alcohols is because they evaporate quickly, especially denatured alcohol and methylated spirits, and they don't leave any residue at all. And that's really all you need. You can go to the dollar store and get one of those stupid CD, DVD cleaners, a little blank CD with a brush on it. I don't trust those things. It's way too much work, and I don't feel like spending $1 for something that's probably going to shred itself inside my unit and leave little nylon fibers everywhere that I'm just going to have to clean out myself anyway. So that's how you do it. Regular old Q-tip, regular old alcohol. Oh yeah, one thing about capacitors. You can break stuff and you can hurt yourself with capacitors. Now I say you can use a multimeter, including my little digital one here, to discharge capacitors, and that's true. But like I said, only for small capacitors. What's a small capacitor? Well, if you look at the side of one, it'll have a rating on it, and it'll say something like, I don't know, 1200 UF at 23 volts. That's a pretty common one. Or 850 UF at 25 volts. Those are used in a lot of power supplies, and you need to pay attention to both numbers. The first one you want to look at is voltage. And right there on the top of my multimeter it says maximum 400 volts. So I'm not going to plug this thing into anything that says anything more than 400 V on it. And the UF rating, that's actually microfarads, that's a description of, think of it as amperage. It's how much capacity the capacitor has. Say that 10 times fast. Well anyway, you don't want to plug any multimeter into any capacitor that's got more than about 2000 UF, and you want to be real careful about doing it at high voltages, you know, anything above 50 or 75 volts, and anything that's got more than 1000 UF. In most electronics, not a big deal. Let's go back to the motherboard wall here. See everything on these motherboards? Little capacitors. 23 volts, 25 volts, a couple of 100 volts, all of them below 1200 UF. See that thing? That's the power supply out of the PBX box. Those capacitors are bigger than a D-cell battery. Those things, not a very good idea to plug your multimeter into. The absolute biggest capacitor in this thing is 200 volts at 100 UF. Peanuts for my little multimeter. Perfectly safe to discharge. Anything bigger than that, I'd be real careful about. So it's 4:30 p.m. on Easter Sunday, and no, it's not a Marilyn Manson song. It's how to find a capacitor to replace this goddamn thing at this time, this date, and this hour. Well, check this out. Pulled it out of an old computer power supply. Yeah, not the same one I used to hot start this thing, but I found another old ET one in my basement. So, if you're looking for weird parts, especially capacitors, to replace one, All you really have to do is look for another thing that does the same job. So now I'll do my very best to show you how to swap out a capacitor the easy and cheap way on a power supply board. First, you want to note that every capacitor has a little stripe on it. This one's got one right there that denotes polarity. And since capacitors are polar, you want to make sure the new one, which also has a little stripe, will go in there the same way. So first, you fire up your soldering iron. Second, you locate the contacts there where the capacitor is soldered in. And then how I do it without a solder vacuum, heat up the solder on one leg, pull the capacitor up, see it popped up, pull it up, heat up the other leg, and just kind of walk it out. Sometimes it takes 2 or 3 heatings. You want to be real careful not to get the board or the part too hot because you can damage them. So now I've got the old capacitor out. You can see, luckily its leg spacing is about the same as the new one. So all we really have to do is make sure our polarity is right. Pop the legs through the board. It's easier said than done sometimes. And then solder the new part right back on. Sometimes you can be cheap and you can actually reuse the old solder. Here I'm heating it up just a little bit to push it through the old solder. Now one leg melted back on, but the other one didn't, so I'm going to have to give it a little bit of fresh solder. Since there's already some there, we don't need to use much. And like I always say, heat the joint, not the solder. Keep repeating it, but people keep not figuring it out, and they keep wondering why they can't make good electrical contact and why they keep chewing up the tips on their soldering irons. So there we go, brand new capacitor. And we should be ready to rock and roll. Here's a quick note because I didn't mention this to start with, but notice that our new capacitor has a higher capacitance rating, the UF number, than the old one. That's okay with electrolytic capacitors in most cases, especially in smoothing circuits. The important part is that the voltage is the same across both, 200 volts. If you're going to replace with a different part, make sure the new part has a higher rating or equal to than the old part, and you should be okay. And of course, the moment of truth. Game is in. Power is on. And away we go. I'm Zero, this is how to fix a Dreamcast, and you've been watching Game.Hack.